You ever have that feeling where you absolutely know the physics, but you're just not sure how to get the marks? Yeah, you're not alone. In this explainer, we're going to crack the code. We are taking one high-value AQA physics question, and we're breaking it down using the official mark scheme. This is your guide to thinking like an examiner so you can secure every single point. Let's do it.
It's the big question in any exam, right? You spend hours revising, but how do you turn all that knowledge into exactly what the examiner wants to see on the page? Well, today we're not guessing. We're going to look at the examiner's secret playbook to see what scores big, what gets ignored, and what simple little mistakes can cost you a ton of marks.
Okay, so here's the beast we're going to tackle. Question 06 from the June 2018 higher tier paper. It's a tricky question all about forces, and it's worth a massive 11 marks in total. I mean, that's enough to seriously make a difference to your final grade. So let's pull it apart, piece by piece, and find exactly where those marks are hiding.
First up, Part 061. Now, on the surface, this looks super simple. A 2-mark task to finish off a force diagram. But this is where we see the first big rule of exam technique. Precision is absolutely everything.
Just look at how these marks are given out. It is so specific. You get 1 mark just for the drawing itself. An arrow that by eye looks the same size as the weight arrow, and it has to point straight up. The second mark? That's for a single specific word, upthrust. Get both of those right, and boom, that's 2 easy marks in the bag.
But, and this is a huge but, here's the crucial warning, and this is straight from the mark scheme. If you add horizontal forces and you draw them with unequal lengths, you lose the mark for your vertical arrow, even if it was perfect. This is a classic exam trap, people. Right plus wrong equals wrong. The lesson? Don't add extra stuff unless you are 100% sure it's correct.
Now, on the flip side, the mark scheme also tells the examiner what to just ignore. So if you use the word buoyancy instead of upthrust, they'll ignore it. And sorry, you don't get the mark. What if you add the value 25 kilonewtons? Totally irrelevant. What if you add correct, balanced horizontal arrows? They'll just ignore those, and you still keep your marks. See? Knowing what's ignored is just as powerful as knowing what's required.
Okay, let's move on to the next part, which is a calculation. And again, it's not just about getting the right answer, it's about showing you're working in the right way. That's how you dank the marks.
For this 2-mark calculation, the mark scheme is looking for a really clear process. You get the first mark just for correctly converting 25 kilonewtons into 25,000 newtons. Simple, right? The second mark is for putting this into the formula correctly. Weight equals mass times g. So you have to write 25,000 equals mass times 9.8. Even if you mess up the final answer, showing these 2 steps gets you the marks. It's a safety net.
Right, we're going to jump ahead now to the main event, the vector diagram in part 6.4. We're skipping over 6.3 because it's another calculation, and honestly, we really need to focus on this diagram. It's worth a huge 4 marks, and it needs drawing skill, scaling, and measurement. This is where so many students drop marks, but we're going to make sure that doesn't happen to you.
And here it is. This is basically the examiner's 4-point checklist. I mean, this is literally point by point what they are looking for. You've got to hit every single one of these to get the full 4 marks. So let's break down exactly what they are.
So let's walk through it. How do we get these 4 marks? Step 1. And your first mark, draw your starting vectors. That's 50 newtons vertical and 150 newtons horizontal. And make sure they're to the same consistent scale. Step 2, for the second mark, you complete the triangle or the parallelogram to find the resultant, and you make sure your arrow is pointing the right way. Step 3, for your third mark, measure the length of that resultant line and use your scale to find its value in newtons. And finally, for the fourth mark, get out your protractor and measure the angle to find the direction. 4 steps, 4 marks.
Now, here's a really important bit. When you find the value of that force, notice it's not a single perfect number. The mark scheme actually allows for a range, from 156 up to 160 newtons. This little bit of wiggle room is built in to account for small mistakes in drawing and measuring. As long as your answer from your diagram falls somewhere in that range, you get the mark.
Phew. But what if you didn't draw it? What if you used trigonometry, like Pythagoras' theorem, instead? Well, the mark scheme has got you covered. It explicitly says to allow a calculated value of 158. This just proves there can be more than one right way to get to the answer, and the examiner is trained to accept them.
And yep, it's the same exact story for the direction. There's a tolerance here too. If you measure the angle from the horizontal, any value between 18 and 20 degrees will get you that final mark. So don't panic if your pencil line is a little bit thick.
And check this out, this is brilliant. The mark scheme gives credit for other correct ways of describing the direction.
Did you measure the angle from the vertical instead of the horizontal? No problem. 70 to 72 degrees is totally fine. Did you give the direction as a bearing? Fantastic. Anything from 288 to 290 also gets the mark. The key thing is to just be clear and accurate with whichever method you decide to use.
So we've gone really deep into this one question and its mark scheme. Let's pull all of this together into a final checklist you can take with you into any exam.
So, what are the golden rules we've learned today? First, use precise language. Upthrust is not the same thing as buoyancy. Second, remember that adding wrong information can actually cancel out a correct answer. Third, always look for those acceptable ranges. Your answer doesn't have to be perfect, just within that tolerance. Fourth, know that different valid methods are often allowed. And finally, always show you're working. You follow these and you're thinking like an examiner.
We've given you a proper look inside the examiner's rulebook. You now know what they're looking for, what they'll accept, and what they'll penalize you for. So the question is, how are you going to use this insider knowledge to change the way you tackle your next exam?